Good afternoon. Welcome to our panel on combating hate speech and discrimination, the use of digital technologies. Instead of having separate presentations, we decided to come up with a joint presentation as a team. For the past 3 years, the Hrant Dink Foundation is conducting this project in partnership with Sabancı University and Boğaziçi University. And we are very excited for having the chance to share the project outcomes with you. My name is Elif, Erol from the Hrant Dink Foundation. We have Didar, Akar from Boğaziçi University Linguistics Department, as well as Berrin, Yanıkoğlu and Arzucan, Özgür from Computer Science of Boğaziçi University. And also we have our faculty members from Sabancı University, İnanç, Arın and Gökçe, Uludoğan. So, as part of our presentation today, we will first provide information about the project background, and also we will talk about pari, AI power tool pari. I would like to start by giving you background information about how the project started by the Hrant Dink Foundation. So how did Hrant Dink Foundation started working on hate speech? In fact, the Hrant Dink Foundation started working on this topic with its first project in 2009, Media Watch on Hate Speech. And of course, the overall process that paved the way to the assassination of Hrant Dink in front of his newspaper offices, and also the way he was targeted in media by means of hate speech. It was, of course, a starting point for the foundation. That's why the foundation wanted to elaborate more on the concept of hate speech and also work on methods of countering hate speech by raising awareness. So since 2009, Hrant Dink Foundation continues to monitor and watch hate speech in print media. And we also do thematic and periodic analysis of our media watch, and we publish reports. And later in 2012, Hrant Dink Foundation started working on other projects, and in 2022 we launched this project utilizing digital technology for social cohesion, positive messaging and peace. The project brings together different disciplines, including computer science, linguistics, and cultural studies. The overall aim of the project is to analyze and detect hate speech and discriminatory speech by means of utilizing AI. So as a result of the project, we have developed the AI-powered tool pari. As part of our presentation, we will offer you more details about pari, and during the coffee break in our foyer, you will have the chance to test pari demo version. Again, the first objective for us was to detect hate speech and discriminatory speech, which is currently a very demanding task and is done by human checkers, and then because of lack of access to data and the bias factor in sufficient algorithms, it is not possible to do this only by means of technology. But on the other hand, because of the workload, it is not also possible to rely completely on humans. That's why we wanted to think of technological solutions for ensuring sustainability. We also are aware that social media companies, they are no longer transparent, and they keep changing their policies. And against such a backdrop, we wanted to bring together different sectors, different disciplines. We will have speakers who will give us examples of how they use digital technologies to counter hate speech. So this is becoming a widespread practice. We believe it is quite important to take rapid action against discrimination. But on the other hand, we need to consider the monopolization of various state-sponsored social media platforms. So it is also quite important, equally important to counter this monopolization. Thanks to this project, we have gained very significant experience enhanced by our partnerships. So after this general framework, I would like to tell you more about the activities we've conducted. We brought together civil society organizations working in the field of hate speech, discrimination, including those from the Middle East and North Africa. We organized workshops for capacity building for the MENA region. We collaborated this meeting in partnership with the International Coalition for Sites of Conscience. So this was our inception meeting, the kickoff meeting, and we still continue our collaboration with this coalition. We produce content with them, and we also publish as much as possible all project outcomes in 3 languages: Turkish, English, and Arabic. We also worked on digital activism, digital media literacy, fact-checking, verification, relationship between civil society and AI, as well as the relationship between conspiracy theories and social media. We also held a number of contests through which we could engage various participants from many countries, and in this way we could collect data and we could discuss different methods for detecting hate speech. Yet another important output for the project is a podcast series called Söylemin Halleri. This was a 9-episode podcast series, and we had focused on various issues such as machine learning, algorithms, and their role in political campaigns, disinformation in election times. Yet another significant output of the project is our publications. We have 2 publications as a result of this project. The first one is Hate Speech, Contemporary Issues and Debates, and the other one is Utilizing AI Against Hate Speech, a Guide to Annotation, Classification and Detection. Both publications are available in the foyer. So we benefited from the input of our experts in our pool, so they all penned one section. And we hope that this first report will offer us an overall framework on contemporary issues and debates around hate speech. And the second report, entitled Utilizing AI Against Hate Speech publication, is mostly penned by our project team. Here we elaborate on the process of developing AI-powered tool pari. We also seek to offer a roadmap for similar projects that might consider adapting pari. Last but not least, this is the main output. Pari, in Latin, pari means equal, and in Armenian it means good. We wanted to pick this name because we believe that the name symbolizes our values as well as our efforts to promote equality. So pari is an online hate speech detection tool, and it allows user to perform a single text or bulk data analysis. So we will first continue with Didar Akar, who will tell us more about data annotation and hate speech categories. Later, Arzucan Özgür will tell us more about the features of pari, to be followed by İnanç Arın, who will elaborate on large language models and AI. Later, Gökçe Uludoğan will take the floor and will elaborate on the models we developed, as well as she will perform a test, an experiment. And last but not least, Berrin Yanıkoğlu will tell us more about the limitations of the project as well as next steps. Okay, over to you.
Ladies and gentlemen, good afternoon. As Elif indicated, in developing this tool called pari, the first step we took was collecting data. And data annotation. I'll talk about this. This is an AI-powered tool to detect hate speech. And to develop such a tool, we needed to teach the AI what a hate speech is. So we created a set of training data. And for that, we collected data. And where did we collect? From Twitter, which later on ended up being called X platform. We collected the posts with time intervals on a regular basis, based on current events, based on annotations and keywords. That's how we collected data. Around 16,000 Turkish and Arabic posts we collected. And in the collection of data, we also thought about the target group. Actually, a target group shaped the process. And in Turkey, some groups are significantly exposed to hate speech. We identified those groups. Take a look at this slide, please. This is the list of the groups we considered in data collection. These groups are being subjected to hate speech. So this was the beginning. Then it was about annotation. Let me tell you more about annotation. We had annotators, the participants of the project. So before annotation started, those people received training. And together with the training, they were given a copy of the guideline concerning annotation. By the way, you could find a copy in the foyer area. And we got feedback from our annotators. And that's how we kept the guideline up to date based on the feedback we got from the annotators. Let's move on. Let me tell you about how we went about annotation. I think that is one of the strongest aspects of our project, annotation. It was quite detailed, meticulous process. Please take a look at this slide. You see the colors. This is like a scale. This is the interface seen by the annotators. We have the label studio here that we used. This is very commonly used tool. Let me tell you what we annotated. First, general attitude and position was asked. That's one question. And there are 4 different answers one could choose. Then target group comes. As we said, this is important. they annotated target group related data. And there is a category about demographic features. Of course, this includes country, nationality, race, ethnicity, gender, or sex. These categories are all under this one. Then, of course, there is more to this, not just these ones. Views, professions, or anti-vaccine people, or flat earth idea supporters. We also clicked those. There's a novelty here actually regarding clicking on the target group. In many examples, we identified more than one target group. It is possible to annotate it like this. Another strength of the annotation process was that the hate speech observed in the text had a certain severity, and you could also choose the severity and rank it from 0 to 10 on this scale you see on the screen. It's color coded. 0, green, then it goes up to 10, red, dark red, meaning the severest. Next step. There's a distinction one needs to make here. We believe this is quite important to make that distinction. Let me explain. Hate speech and discriminatory discourse, different things. In the description of hate speech, the framework or the borders, I think, includes a very familiar concept, freedom of speech. There is a blurred line between the two concepts, but when it comes to discriminatory discourse, the lines are not so blurry, quite clear. Freedom of speech and discriminatory discourse, they sometimes get confused, so discriminatory discourse was coded differently, separately. Next. Once you identify it is a hate speech, you determine the category of hate speech in the process. There are different categories. And actually, this is another strength of the project. Next one, please. Excuse me, the one before. Please take a look at the bottom, the color-coded part at the bottom. There are categories. And I want to introduce to you the colors in determining the severity. We intentionally actually chose these colors in the scale above toward dark red, but at the bottom, the color decision was not so intentional. The categories I'm referring to here, it's just different colors. They are different categories. What are the categories? Some of you may already be familiar due to the Media Watch studies that you follow, conducted by Hrant Dink Foundation. There are 4 categories. So, the Martians are the hate object. We've never met a Martian, but still we do have the examples. The first category is symbolization. Stop talking like a Martian, quote unquote. In such a text, a reference to Martian, someone from the planet Mars, but this is an insulting discourse in the context. Next, second category, exaggeration, generalization, attribution, distortion. Category 2. I had to wait for 1 hour in the metro station because of families who have 10 kids, quote unquote. exaggeration, generalization, attribution, and distortion. What does this mean? How do people count? How many children do they have? How do they know whether they come from planet Mars? Why do you think it's because of those families that they wait for 1 hour in the metro station? Well, let's move on to category 3. What was that? Okay, swearing, insult, defamation, dehumanization. It speaks for itself. Quite obvious. And the last category, and the name also suggests actually what it is quite clearly. Threat of enmity, war, attack, murder, harm. Another example regarding those who come from Mars. In the field, there are similar tools like pari, and the most widely used was creating a binary classification. There is or there is none. I mean, hate speech. Whereas in our case, it's more delicate, layered, and it's easier to teach the tool. So it's not binary like yes or no. No, it's beyond that. It's more intricate, more sophisticated. Just to clarify that. Regarding annotation, another strength of the process was that in our system you could choose more than one target groups, more than one category of hate speech. You don't have to restrict yourself with one category, because that's usually what it is. In a text, you sometimes see more than one target groups, more than one strategies deployed. And in the training set, this needs to be represented to develop the machine learning process. My third point is each text evaluated by 3 annotators. And for final decision, we chose the method of majority of vote. In terms of perception of hate speech, we know it's quite subjective, this perception. It's not like black and white. That's why we did it based on majority voting. And that's why we had 3 annotators. This also tells you a little bit about the high quality of the data set, clearly. So far, we have told you about how beautiful our annotation system is, what strengths we had, but to tell you the truth, we faced significant challenges as well. So what were those challenges? Let's take a look. As I said before, subjectivity is an inevitable part of this process. One becomes subjective based on one's life experience, background. So some annotators might have more sensitive attitude regarding some contents. Unfortunately, that is how it is. It's in the nature of this work. So there is this subjectivity. That was number 1. 2, second challenge. Especially on the social media platforms. Because of the control on these platforms, there is language usage, coded language usage, like a risky word that the algorithm cannot capture. For example, omitting the vowels in a word or replacing a vowel with an asterisk in the word so that it wouldn't be captured by the algorithm, or using an abbreviation instead of a word, or using emojis and symbols. It's also a part of it. It was hard to teach the machine about interpreting these. Third point, challenge. Hatred was not always openly stated. Sometimes it was implied or covered, or it was contextual. That was another challenge. So one needs to know about the background, about what had happened before to make sense of it. Otherwise, that utterance may look quite innocent, but actually it's not. So one needs to know about the background. This was another challenge. Point 4. Sarcasm and irony. This is for hate speech, this is for the AI. It's quite a bit of a challenge still. Humans have at least some superiority when it comes to sarcasm and irony. So machines have a hard time capturing that, especially with written texts. It's not easy for the machine, for the tool to grasp that. Normally, the tone of your voice would tell a lot about sarcasm or irony, but written texts don't give you that opportunity to express yourself with your voice tone. And lastly, I would like to talk about missing visual context. Tools like Pari cannot involve these visual contexts. The text itself might be quite neutral, like a picture from a meeting from yesterday, let's say, but actually there is a picture associated with it, or comics associated with that written text, and that visual content may significantly change the meaning. And this was another challenge we had. That's actually all I wanted to say about annotation. I want to hand it over to Arzu. She will tell us more about the technical aspect of this work. Thank you. Good afternoon. I'd like to talk about main features of Pari, what it could do, what tasks it could perform. It is the latest technology, AI-powered tool in this area, and in terms of our daily life, technical aspect, large language models, ChatGPT, BERT, DeepSeek have introduced significant changes in our daily lives. And this software is like that. It is in Turkish and Arabic text support. This is an important characteristic. It is available in 2 languages. And these are, if I may say so, rare languages compared to some other common languages. Another characteristic was it's open source coded. So you could easily we could tell how it does what. It is AI-based LLM model, meaning a large amount of text data used to train the model. The features of a language already learned by the machine. In identification of hate speech, in terms of analysis of hate speech, by using these models, we give it special tasks, and we're trying to improve the tool to make it more successful. It was pre-trained already, as Dilber Hanım said. We meticulously detected, annotated data, and that's how we could introduce different tasks in terms of detection of hate speech. That's how we trained the tool. Basically, this slide tells us the components of Pari. First, identification module regarding hate speech. This is the first component of Pari. When you enter a text to Pari tool, then Pari will tell you or make an estimation of whether there is a hate speech there or not. Actually, Other tools could also do this. But the edge of pari is it's more detailed in terms of its analysis. For example, the second module, which is about category and level detection, which means there are 4 different categories you could allocate your text to. It could tell you whether there is or there is no hate speech. It could tell you whether there is discriminatory discourse or whether there is exaggeration, symbolization, or threat of enmity or war. It could tell you this too. So it's quite detailed and sophisticated in this category. In addition to that, it could make a guess of severity of hate speech on a scale of 0 to 10. It could make an estimate. 10 means the severest hate speech. And 0 is basically saying there's no hate speech or discriminatory discourse. Another module is about target and identification of target and group. Race, ethnicity, country, nationality, or religion-based, or sex, or gender-based hatred or discrimination, it could tell you. And there is more in terms of target groups. For example, basically is it refugees, Jews, women, and so on. Which group it is specifically, it tells you. There are around 11 such groups. And the last point here, if you enter a text, the text may not entirely include hate speech. Maybe some parts will include hate speech. And pari will tell you which word or groups of word cause hate speech. So it could make such a guess. Let's take an example. Again, target group is the Martians. Hoping there's no Martian here in this hall with us. So, these Martians always cause trouble and headache, and they give us a big headache in our society. Let's say this is the sentence. The first component, the first module, tells you whether there is or there is no hate speech. So it says there is hate speech. How about its category? Detected. Generalization, exaggeration. That's the category here. Attribution, distortion. And the level of severity is 8, according to pari. And in the third module, based on this example, the target is race, ethnicity, country, and nationality. And target group, Martians. And last module, word identification. Which word or words? For example, trouble, cause trouble, gain control, they ruin our society. Groups like that. So these are the general characteristics, and it's over to İnanç, and who's going to talk about the technical aspect. Thank you. Good afternoon. I will talk about the technical aspect. As the previous speaker said, this works in Turkish and Arabic, classifies, identifies hate speech, and it's an open source tool. How did we create this? From social media, from printed media, visual media, we collected data and we annotated data. And this was given to the LLM. It learned and it was tested. Was tested. And Gökçe will share with you the test results. But for now, it's based on LLM. What is it all about LLM? How does it work? How does it learn? I'm not going to give you too much technical details, just a general idea. Large language models is a artificial intelligence model designed to understand and produce human natural language. This is LLM. It's ChatGPT, Gemini, or from Meta, Llama, or DeepSeek in the past weeks or months. These are some examples to LLMs. There are, of course, other examples, hundreds, thousands of LLMs. So which one should we use? It depends. But I'm not talking about our daily use. I'm talking about professional use of LLMs. What are the criteria? Is it open source or other closed source? Like OpenAI, ChatGPT. That model is not open source coded. Professionally, it's based on API, you need to pay for it. On the other hand, Llama by Meta or DeepSeek are open source coded models. You could download on your laptop, use them free of charge. But it's also coming with a certain cost. These are not small models. You need to have strong servers and devices. Having mentioned the cost is another criterion. The same model have different versions with larger parameters, smaller number of parameters. But this impacts speed. You want something speedy or slow, maybe faster, but a little bit less performance, or you may choose slow but more successful. So it depends. What else? It depends on for what business or work you need it. Is it for categorization, classification, or is it for producing something? Text, test. Then you could use ChatGPT, or you want to work with visuals, multimodal. The examples like Gemini or Grok, maybe by X, quite good with visuals. Or maybe you are a developer, then Claudio Sonne could be your preference. So it depends on what problem you would like to solve. You need to choose the right model. So you need to be conscious about the decision you make in choosing these models. What problems can we solve with the LLMs? Let's look at this. Mainly, as a summary, I could give you some, just a few examples. 1. Text classification. Given a certain text, it could tell you the classification of that. For example, you all have social media accounts, or we have email accounts like Outlook or Gmail, whatever. You receive an email, and these LLMs categorize the incoming emails, whether it's spam or for inbox. You could have different categories. So that's what it can do. 2, it could answer questions. Like, what is the capital city of France? Paris. So this is what the model can do. Or you could talk to the model saying, I'm going to ask you a question, but I'm going to share with you a PDF by my company. Please search for the answer within this PDF file. You could also make the machine do this. Next, text summarization. Consider a hundreds of pages long document you need to summarize. Next word prediction. Let's say the AI will turn the world into fill in the blanks. It changes the world, it transforms the world into this and that. So the LLM could also do this. So how do these models learn? It depends on what kind of model we're talking about, because there are thousands of different models. And in a given model, there could be two ways. Under the first one, it could have auto-encoding. In the second category, it could be auto-regressive model. So how to tell them apart? So it depends on how they learn. If it is auto-encoding model, then let's say this sentence. Artificial ... models are trained by large data. So there is a missing word, and the missing word is intelligence, artificial intelligence. So you want the model to guess what word it is that is missing. Sometimes it could give you wrong answers, and if you incur some costs, you could update the model to improve its performance in giving answers. That's how it learns.
Let's take an example here. In this project, we use BERT, bidirectional encoder representations from transformers, and it was in fact trained by using this very model. So another large language model is autoregressive model. This also is a similar model, but here the masked word is not placed in any part of the sentence, but it always is located at the end of the sentence. So here you see the output. For the output, the masked phrase is trained and enhances its capacity to process natural language. By the way, DeepSeek is also an autoregressive model. How does large language models LLM work? This is like a very big nerve network of nerves. We give here a sentence and we ask the model to make a prediction. So this is where we feed the sentence, and this is our mask, and we expect the model to predict for us. So there is a specific word that we type first. Perhaps word is not the right way to define this. These are actually some numeric structures. I don't know if you have seen the movie Matrix, because everything in Matrix is expressed in terms of numbers. So here, these words are actually represented by a group of numbers. So we take this numerical data, and then based on our next task, be it classification or identification of severity or identification of spam mail or not spam, we would train the models. And through this training, we can adapt these models for different tasks and functions. So coming back to our project, we have a classification task. In the first phase, we have a binary classification. Of course, we have other subcategories such as exaggeration, symbolization, but initially, at the very first stage, we have a binary classification, and this classification involves there is hate speech and there is no hate speech. And then we have the other categories, as you can see on the screen, but this is not a 100% subjective assessment, because for instance, when we talk about discriminatory discourse, for some, a sentence might amount to a discriminatory discourse, but for the others, it might not be the case. So there is always this bias factor. So we have a second layer of classification. So at this next layer, we have different hate speech subcategories. And you see here number 3 and number 4 are grouped together, and number 5 and number 6 are grouped together as well, because we notice that our model will give much better results. But for the purpose of another project, it might be more appropriate to combine the 4th and 5th categories. So as a result of all these classification exercises, pari contains 6 models. We have the binary classification, 4-class classification, and then we have identification of severity. Okay, let's assume that we established that a text contains hate speech, but what about the severity of hate speech? We want to represent the severity of hate speech in a scale, and to understand where the hate speech should be represented on the scale from 0 to 10. You might remember we had some parameters like hate speech based on ethnic origin, gender, or being a Greek, Jew, woman. This represents our classification based on the target group. Then we have the group-based classification, and last but not least, we have a word-based analysis. Which particular words in a given text contain hate speech or amount to hate speech? So this is all I would like to share, and let me give the floor to Gökçe. Yes, in a little while, we will have the chance to work on the pari demo. We will be able to test it. But let me first tell you about the features of pari. So pari currently has an accuracy rate of 85% in Turkish and 80% accuracy rate in Arabic. Right now we are using different models for both languages, so we did separate training. In case of Turkish language, once again, pari gives us accurate results, 85%, and in Arabic language, pari has an accuracy rate of 80%. But when we work on analyzing hate speech, we should not only focus on accuracy rate, but we should also understand the errors as well. And we need to understand the type of errors. So we see two types of errors. One is false negatives and false positives. So when we talk about false positive, the model would predict as if the text contains hate speech, but in reality the text would not contain hate speech. And when people use pari for moderation, this false positive would be quite important, because then this would be a red flag. The system will give you a red flag, but this red flag would be wrongful. And this false positive in Turkish is 17%, whereas in Arabic the false positive is 6%. So we also have another category here, which is false negative. So when the model makes false negative, it means that according to the model, there is no hate speech detected in the text. However, in reality, the text contains hate speech. So the false negative rate in Turkish is 15%, and false negative for Arabic texts is 27%. So although our tool maintains a high level of accuracy, we still need to pay attention to the possible errors. So I would like to give you some examples to better demonstrate how pari works in action. So this is the main interface, the main homepage of pari. This is our AI-powered tool. First, you need to subscribe to use pari. So you click on Parile, and then we will see the analysis screen, and here you see different predefined examples. But once you subscribe, it is possible for you to perform both single and bulk data analysis. And once you click on subscribe, you will see there are two options: standard subscription and professional subscription. Standard subscription allows you to do single data analysis, and professional membership allows you to perform bulk data analysis. Professional subscription is not yet activated, so let me click on standard subscription. I will be just subscribing for myself with my personal data. Yeah, this turned out to be a real demo. Thanks for bearing with me again. Okay, so now that we are subscribed, we can proceed to analysis. By the way, pari is available in English, Turkish, and Arabic. From here, you can select your language of choice. So the interface itself is trilingual, but the pari tool can only analyze text in Turkish and Arabic in two languages. So we have some predefined examples of hate speech where hate speech content is quite obvious. This is our first example. Education in Kurdish is unacceptable. We click on Analyze. So once we click on Analyze, pari gives us the results. So in the first row, we see whether there is hate speech or discriminatory speech. And yes, pari detects hate speech or hate speech, and the category is discriminatory speech. The severity is 6. So we have a hate speech based on race, ethnic origin, nationality, and the special group is Kurdish. So pari makes an accurate prediction here. And another predefined example: you should always avoid female drivers. We analyze, and here pari successfully detects a discriminatory discourse here. The severity of hate speech is estimated as 6. The target identification is gender, sexual orientation, and the special group is women. So these are the predefined examples where pari gives us 100% accurate result. Let's take another example. Non-Muslims should not be members of parliament. We analyze this sentence, and pari considers this as discriminatory discourse. Severity is 4, and general target identification is religion, which is correct. But when we look into the special group, target group identification, we see Jews here. Although the original text talk about non-Muslims. So pari was able to identify only one special group, but could not predict the other communities or groups. Yet another example, a similar predefined example. There are no jobs left for us because of foreigners. According to pari's analysis, there is a hate speech here. And according to pari, the category is exaggeration, generalization, attribution, distortion, with a severity scale of 5. and general target group is hate speech based on race, ethnic origin. As for the special target group, pari could not identify a specific target group here because we did not feed pari with the word foreigners here. That's why pari could not really identify the specific target group. That's why it's quite important to be as specific as possible. So these are the predefined examples. And then we also have different functions and features that pari offers. For instance, we can enter here a text, an entire text. Okay, this will be an ironic example. We celebrate your new year with 5 million refugee brothers and sisters. So we analyze this. And it seems that pari cannot recognize any hate speech or discriminatory speech in this particular text. And by the way, we use caps lock here. And there was also exaggeration because it talks about 5 million refugees. And this would also be a vague statement. We would not easily, as human annotators, we would not easily tell whether it contains hate speech or not. But pari, according to pari, this is not hate speech or discriminatory speech. Let us also proceed to more complex examples to better understand the capabilities of pari. Don't speak like an Armenian. Once we analyze this through pari, pari tells us that there is hate speech. Don't speak like an Armenian. So there is symbolization with a severity of 6. And of course, a specific race or ethnic group is targeted, and a specific target group is Armenians. Our next example, we might suddenly come overnight. So this is a generic sentence, and just by judging from the sentence itself, we cannot actually find any specific target group, but if we know the context, we would understand that this is a statement targeting Greeks. And for instance, let us now look at pari, and pari successfully predicts that the statement is towards Greece. The category of hate speech is insult, defamation, dehumanization, and threat of war and enmity, with a hate speech severity of 8. One last example. If we normalize these perverts, the country will collapse. Here, the target group is not very obvious, but again, since we know the context in the country, we can clearly understand that the targeted group here is LGBTI+. Then the general target is gender and sexual orientation, and it clearly contains insults, swearing, and dehumanization. And pari gives us successful results here. So with that demo, we wanted to show you how pari works on single text, singular texts, and in the coming days it will also be possible to upload files and make analysis based on files, but this feature is not yet enabled. we will soon invite you to foyer area so that you can test the demo yourself. But let me now turn to our expert Berrin Yanıkoğlu, who will tell us more about ways to improve pari. Okay, I will now be sharing the last 3 slides. My colleagues have already covered a lot of information, but let me also share with you that it has been a great pleasure for us being part of this project. We worked on the number of classifications, on hate speech categories. We want to understand how we can train our AI tool more robustly. And along the way, we made certain decisions. And of course, as the computer scientists, it is quite easy for us to work on identifying language models for artificial intelligence tools. But then, of course, it was difficult for us to understand the context, labeling, distinctions between different hate speech categories. So this was not quite obvious for us. So we benefited a lot from having this multidisciplinary approach. So we have actually already referred to some challenges. One of them is subjectivity in data annotation. In order to address this, we constantly discuss this issue of subjectivity among ourselves. We refined our groups, our categories. We also improved our guidelines. We also want to understand how we can simplify the model. So that's how we started with the initial question. So we asked the model a very simple question, whether a statement it contains hate speech or not. So we constantly improved the model, and we wanted to come up with inclusive labels. What do I mean by inclusive labels? The project involved many researchers, students, volunteers. They annotated data with certain labels based on hate speech categories. And we wanted to be as specific as possible, as detailed as possible, because we want to also share our literature with others. One novelty the project brings us was about annotators' agreement or voting. So if 3 annotators consider a phrase containing hate speech, you pick it and focus on them. But then we came to notice that this is rather a shortcut, because it only works in the obvious text. When we have 3 annotators agreeing on hate speech, then we might also miss some subtle hate speech. So we realized that we both need a simplified procedure, such as it contains hate speech, it doesn't contain hate speech, but we also need more sophisticated labels to uncover more subtle hate speech. That's why instead of 3 annotator agreement, we also worked on majority, so majority annotator votes. And another limitation in this study was the lack of context, because pari is able to analyze only the single entries. And when we consider threads or tweet threads or floods, it gives us also the context. Of course, we are still in full alignment with the literature, but this is yet another limitation we have. Encoded language or covered hate speech, hidden hate speech is yet another challenge. Here we see that people use emojis, certain symbols in order to share their messages. If you turn hashtags into words, or if you turn emoji symbols into words, then you can cover a lot of ground. This is what we did, but then it is more difficult to take into account cultural references. Another weak link for us was the sarcastic content. So you see a text or a statement, and at first sight it might look totally normal, but you need to be able to understand whether it contains sarcasm or not. Further limitations we encountered as part of this project. One of the major problem for us was accessing data because of the micro and macro policies of social media platforms. There are certain quotas, so we only had an access to limited number of tweets. Another challenge for us was lack of context, because we are only able to analyze a single or singular entries, texts, but we cannot actually perform these tasks in the threads. And also we have limitations when it comes to analyzing the spread of hate speech, because we're discussing the problems of disinformation, misinformation, hate speech. It would be really good if we could also have a better understanding of the spread of hate speech. As for the way forward, we have some suggestions. Let us think of ChatGPT. We want ChatGPT to fully read the text, to fully understand the text. So perhaps we can migrate to larger models with capacity to collect larger data sets. We might introduce additional labels to improve the models. I believe this is all I wanted to say. This was a great project. I would like to thank all our team members, Hrant Dink Foundation, or all our collaborators in the network. Thank you.